Okay, in this part of the lesson, we're going to be working with comparing scientific notation. So there's a couple different ways that you can do this. So we'll start out first of all with how the book probably prefers you to do it, and that would be to convert them to standard notation, because in this part of the lesson, you worked with converting scientific notation into that standard form. So we're going to go ahead and start with that. It says an object with lesser density than water will float. An object with greater density than water will sink. Use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. So we want to know which one floats, which one sinks. I know common sense wise you can tell me, but we're using this common sense problem to help you understand scientific notation and use it as a self-check. Okay, so we're going to go ahead and convert this into standard form. So we're going to look at our exponent, which is 3. It's positive, so we're going to go to the right 3 places. There's 1. I'm going to add 2 more zeros, so we have 1,000 kilograms per meters cubed or cubic meters. Okay, our brick, once again, 3, it's positive. We're going to go to the right. 1, 2, 3. We're going to add a 0, so 1,840 kilograms per meters cubed. And then our apple, 2 places to the right. 1, 2 gives us 641 kilograms per cubic meter or meters cubed. Okay, so now they want us to go through and compare. So you have water that's 1,000 kilograms per cubic meter. Anything that's above 1,000 is going to sink. So our brick, well, this is above 1,000, this is going to sink. Okay, anything below 1,000, this is our reference point, is going to float. So this is below, this is going to float. And I know, common sense, you guys already know that, but this is going through and having you work with comparing those. If we didn't have the scenario and they just gave us each of those scientific notations, we would have to understand how to compare them, okay? So the other method that you can use, and some of you will pick up on this, is instead of changing them into standard notation, the other thing you can do is you can go through and actually compare our exponents. And I apologize, my smartboard just shut off on me all of a sudden. So if we look at these exponents and you find the exponents, you have a 3, and a 2. So the 2 is smaller, which tells us that's going to be the smallest standard number. Okay, these are both 3s, so those are the same, but then we would look at the number here in front. And so we would say, well, 1.84 is bigger than 1.0, so this would be the largest number. So that's the other way that you can do it, is you can also compare those exponent numbers.